All right, hi everyone. It is Friday and it's time for our studio review. This week we introduced you to excuse me, a very important concept called methods, which we're going to be using a lot. So this studio was somewhat in-depth in the sense that we had a lot of ground to cover, a lot of different topics that we kind of wanted to introduce you to, and I know that many groups did not make it all the way through this studio, and that's okay. Honestly, we try to make the studios long so that you stay and work and get as far as you possibly can. And I will go through the whole thing right now. So let's get right into it. I've already made a repository and imported it into Eclipse, so we don't need to worry about that part. The way that this studio works is a little bit different. In fact, I got a few questions right off the bat because most people, I think, understood how to code up a simple distance between method, right? Using the distance formula. But how do we test it? How do we run this? And so the instructions first kind of explain that we're doing this a little bit differently now. We're writing methods and then we're also writing tests that make sure that our methods do what we want them to do before. We write tests to make sure that the methods perform the way that we expect them to perform. It's also important to note that tests are written by people, though, so they're just code. And so we can look at those tests and understand what they do and understand how to write those tests. So that's part of what's in this studio as well. So we're going to be writing all of our methods inside of this methods file. There's a test suite that has other tests in it for the various methods that we're going to be writing, and we'll be looking at those tests eventually, as well as a debug app for the visual method that we're going to be writing. And then as we go, I'll just review all that stuff as we start writing. I'd like to go ahead and start writing some code. We're going to go ahead and take a look at this distance between method that I already showed you just a moment ago. This is a very function-like method, meaning that it gives us an output that is based on its inputs. So it's very important to understand, for example, that these values here could be anything. They could be any numbers that we possibly could conceive of as points, as x-y coordinates. So there are, of course, limits as to how big and small values I can represent on the computer, but for all intents and purposes, we need to write this method to work for any possible value that I might expect to be given to us for x1, y1, x2, and y2. So this is the idea of trying to generalize or abstract out the idea of computing the distance between 2 points, right? I can tell you how to compute the distance between 2 points without having to actually know what the 2 points are. So let's go ahead and try this. It involves the distance formula, which if you have to look it up, there's no shame in that. I believe it's going to be the square root of, what is it? It's x2 minus x1 times x2 minus x1. I believe. And just switch these to be y's. I'm going to Google this to make sure that's in fact the case. I'll just use my phone here real quick to make sure that I'm doing this properly. Distance formula plus, yes, I believe that's okay. If it's not, we'll find out momentarily because we have tests that we actually can use to check our work. So one thing that people try to do is they come to this methods file and they want to run it, but there's no way to run it. And the reason why there's no way to run this is because there's no main method. So every single program that we've asked you to write up until this point has included what's called a main method. In fact, that's where you've been doing probably all of your work up until this point, is in the main method. And the reason for that is that the main method is the entry point into a program. It's the very first method. It's where every program begins, is it a main method. But we can have other methods. We can have as many methods as we would like. And so a lot of times our work is going to be done in those other methods. And the fact that I can't run this file doesn't mean that I can't use this method. It just means that there's no entry point here. There's no main method here. There's no way to kick things off. So if I want to test this method, for example, I have to run the test suite, which some of you have seen through the extensions, but if you haven't, this is your first introduction, you can see that, okay, I did get this equation right. Or mostly right, it appears, because the green checks mean that it's passed the tests, but there appears to be a red X down here indicating that one of the tests has a problem. Well, let's take a look at these tests and see, what's going on. What is actually happening with these tests? So the first test that I'm looking at, it tells us right up here at the top, it's testing to see that the distance between a point and itself is 0. It should be about 0. So you can see here that the way that we're doing this is by calling an assertion. I'm asserting that the value 0, this is the value that we expect to get as the distance. This is the value that I am expecting to be the distance between 1 and 1, should be the same as calling our method. So this is using our code, right, to compute the distance. This is saying that our code should return 0 if I tell it to compute the distance between 1, 0 and 1, 0, because these are the values that have been fed into the method. Now, in computer science terminology, what we are doing here, this is a method call. So when I use a method like this, this is a method call. And these values here are the arguments. So the actual numbers that I'm using, the 1 and 0 values in this case, are the arguments. So when that happens, you can see that I'm actually going to go into the distance between method, and now it's going to run it, where x1 is equal to the first value that was fed in, 1, x2, or y1 is going to be equal to 0, right? x2 is going to be equal to 1, etc. So that's how this is going to execute. It's going to compute the value. It should be 0, which it will then return, give the value out of the method, and then it compares that against the expected value, 0. However, there's one final value down here, which is a tolerance, or a delta. So the reason why this exists is because we are allowing for some imperfections to occur. This might seem a little strange or a little silly. How could computation effects occur with such a simple example, 1, 0, 1, 0. That seems like there's such simple numbers. How could the computer, excuse me, encounter rounding errors or something like that? And the answer is, well, it's a bit complicated. It has to do with how the numbers are represented on the computer, more than the operations that are being performed. If you'd like to know more about it, I would love for you to come talk to me about it in office hours sometime. I can explain to you in more detail. But for now, we should know that when comparing two values, we usually do so with a little bit of wiggle room, a little bit of tolerance. You can see the tolerance is not very big, 0.00001, but we do allow for there to be some deviation just to account for the fact that there's going to be some just random errors by chance that happen due to how the computer needs to do its work. So this test passes, which is great. However, we can see that this test down here at the bottom does not. And if this ever happens to you, I think that you should click on it and then look down here. It actually is trying to tell you what the problem is. It says, I expected 50, but the answer that I got was 10. So if we think about what that means, it's saying, well, in this test, which we're going to look at in just a moment, it was expecting 50 here. But when I called the method for whatever values that are in that test, it got the value of 10 back instead, which is a pretty big difference. Well, let's go look and see. So now we can see that this test, there's the 50. Here's the method call. And the comment tells us that it's trying to test the distance between 0, 0 and 30, 40. So this is a classic 3, 4, 5 triangle, right? 3, 4, 5 right triangle. But you can see that there's an error here. So the way that this should be called with the method, the order that the parameters appear is not the same as how I would expect them to appear here. So I expect it to go x comma y, x comma y. But instead, it appears to go x comma x, y comma y. So there's an error in the test. I said I was testing one thing. I wrote the test with one expectation in mind, and the test failed not because my code was wrong, not because this code was wrong, but because this code was wrong, because this code did not match the expectation that was set. That's very important to keep in mind, right? We are giving you these unit tests. However, those unit tests were written by human beings, by people. I wrote some of them, as well as other professors who have taught this class, and students for that matter. So, you know, there can be mistakes in unit tests, just like there can be mistakes in the code that you write. So keep that in mind. The tests are a helpful tool for us. We do use them. I'm not trying to tell you that there's a bunch of problems with using tests. I'm just asking you to keep these things in mind. The reason that we do like to write tests is for the reasons that you see here. I had an idea. I wanted to write a method that computed the distance between 2 points, right? So what happened? Somebody was nice enough to give me some tests that I could use to check to see if I had found a way to do that successfully. So the name of the method was defined, distance between, the inputs and the order and the type were all defined. And so these tests were written ahead of time, and I could use them to check my work. This is an idea called test-driven development, this idea where tests are written before the actual functional code is written. That way it helps us define our expectations, right? What are we doing? What information needs to go into a method in order for it to work? What information is going to come out of this method? We actually use these tests in this way. And so it's nice to have these tests to check our work, as you'll see as you go through the next several homework assignments, because we're going to keep giving you unit tests like this. All right. On to the next. So we already did this part, I believe. Excuse me. We did the testing. One test case fails, and we fixed it. All right. They want us to add another test. So let's do that. Once all tests pass, we're going to add one more test, test points E, that will verify that the distance between these 2 points is 5. Let's go ahead and do that. In order for us to do this, we need to look at the other tests and examine what the parts are. The first part is this right here. This is actually something that's called an annotation. Anything that starts with an @ sign in Java is an annotation. @test is simply an indication that the method that I'm about to write is for testing purposes. The rest of this we can just copy. This is called a signature. It looks a little bit different than some of the signatures that we have seen. In particular, it's missing that word static, but I'm going to ignore that for now. We'll come back to that in a future module and just continue on with writing the test. And then at this point, I'm honestly just going to copy this line and paste it in and swap out the values. This is programming. Don't feel bad about doing this. I want the answer to be 5. That's the expected value. And these are my 2 points, 8, 9, and 5. 5, so distance should be 5. I'm going to change the values going into the method call to be 8, 9, 5. 5. I'll leave the tolerance alone because that seems to be okay. And now let's rerun our tests and see. All right. Not only did the fixed test pass, but also the test that I wrote passed as well. And we now have additional proof that the method works the way that I expect it to work. Okay. Now we're going to take a look at a method that doesn't return anything. So the last method, distance between, gave us an output. It gave us a return value. Specifically, it gave us a value called, or it gave us the distance, rather, as a double. We could see that in the method given as its return type here. Also indicated in the java.doc comments above as well, right? The next method that we're going to look at is a void method. So this method doesn't return anything, and typically void methods are used to display information most often, right? Not always, but that is a very common use of void methods, is to display information. So in this case, we're drawing a bullseye on the screen. It could also be printing some information or drawing some other kinds of pictures or whatever the case may be. But in this case, we're drawing bullseyes. And so you can see that we do have parameters up here, 3 of them this time, where X and Y are where the bullseye begins, I'm sorry, the center of the bullseye, according to the Java.doc comments. And the radius is how big we want the entire bullseye to be. So how big is the entire bullseye? So if you run the bullseye debug app right now, before we've written any code, what we'll see is that we've done the black circle for you, right? Here it is. We used filled circle. We plugged in X, Y, and the radius, right? And if you continue, you can see that it tries to draw more bullseyes using the method, right? Okay. But we need to do the rest of the circles. So we now want to do a blue ring. So you could do the blue values suggested here if you would like, or you could use the plain blue values. But either way, we do need to make the radius smaller, right? We need to make it smaller. In fact, they ask us to use 3/4 of the radius. And it's very important that the 3 and the 4 are doubles, right? Or at least one of them is, so that the math comes out properly and this doesn't do integer division. Okay. Let's run it. Let's run that debug app again and see what happens. See if we get our blue. There it is. Okay. Looking good. Now we'll do the red one. This time with half the radius. And I'll go ahead and add on the yellow one while we're at it with 1/4 of the radius. And we can now go ahead and take a look at the finished product. There it is. There's our bullseye. Upper right corner, upper left corner, lower right, 4 bullseyes. That's great, right? If you look at the draw bullseye debug app, it's actually, what is this doing? Maybe I shouldn't have looked at this. That's funny. Draw bullseyes, .get cases. Interesting. Never mind. That was not a good direction that I should have gone in. Let me return to the instructions and stay on the beaten path. All right, we did the bullseye. Great. And we did the test. All right. The next method, substitute all. This is the one, this is the first method I think that really gives people a lot of trouble. There's more than one way to accomplish this, so I'm going to show you one way that you can complete this method. It's actually pretty straightforward. It's not particularly complicated, but that doesn't mean it's the only way to do it. I saw many solutions, so if you came up with a solution that's different than the one that I came up with, then great. But this was a pretty tricky problem, so let's get into it. The idea here, I think it's important first and foremost to understand what it actually is that we're trying to accomplish. So substitute alt has 3 parameters: a source string, right? This is where the substitutions are going to be performed. So this is you can read the instructions here, but I'm actually going to just draw you a little illustration that should hopefully make it clear. The target is a character. So this is the letter within the source that we are looking for. Okay, and then finally there's a replacement string. So anytime we find the target, we're going to replace it with this. So as a simple example, we could actually probably go look at the methods, or we could even, yeah, let's just go look at one of the tests for substitute all. Okay, here's the source, right? R is a R is a R is a R. Here's the method call. It's plugging in this big long string. It's saying go look for all of the letter R's. And anytime you find the letter R, I want you to replace that with the word rows. So it's going to go through here. Here's a letter R. Plug in the word rows. Here's an R. Plug in the word rows. So it's going to substitute. It's going to substitute it in. All right? Here's another substitution. B is T, T, B. So substitute beauty in every time you find the letter B in this string, right? You can see that there is a little bit of a side effect if you try to run it twice, because when you run it a second time with T, you get this weird betruthy, which is kind of funny. Anyhow, hopefully that illustrates what we're trying to accomplish. So I think, as I look at this method and try to figure out how to accomplish what it is that we're doing, I need to look at every single character. I need to look at the first letter, determine, is this the one that I'm looking for? If it is, if it's the one that I'm looking for, then I need to use the replacement, right? If it's not the one that I'm looking for, so if I look at an O, I just need to pass that through somehow. So we gave you a big hint here, actually, with this method. When we gave you this string variable called result, and also in the instructions, we highly encouraged you to use concatenation. So take your result string, right? Go through every character of the source. If it's the target that we're looking for, then use the replacement. Otherwise, just pass the character through untouched. Let me show you what that could look like. So we're gonna make a loop to go through the entire length of the string. Okay, using the length method here to ask how long this string is. We're then going to get the character from the string, which we can use with the char@ method right here that we linked you to. Or, well, that's broken actually. I need to go fix that. My apologies. But anyway, you can use the char@ method. So if that is equal to our target, then we need to do the replacement. You could even comment these, right? Replacement. No replacement. Okay? But the replacement is actually not that complicated. I have this result string here. So if I need to do the replacement, I'll just concatenate that onto my results string. Otherwise, I'll just concatenate the source character. I believe something like this should probably do the trick. Let's run our tests and see. Okay, there we go. We got green check marks. That's good. They all pass. Great. All right. This was a little bit sloppy the way that I did this. There are some questions asking what I could do to improve the code. One thing that I don't like here is that I used char@ twice. I think that if I'm calling a method like this twice close together, I think it might be a little bit better to make a variable for that instead. So, you know, take the method call out of this and replace it with a variable. The reason being that I can now have a better description of what the code is doing. You'll notice that just that one simple change, right? That one simple change makes this block of code a lot easier to understand just from reading it. At least in my opinion. I know that's somewhat subjective, but I think that makes it easier to understand. So there's a small little improvement that could be made. Okay, on to the next. Using arrays as parameters is a pretty complex thing for people to consider when first using methods. So this idea that I can now take arrays, which are still complicated for a lot of folks, and then also have them as parameters. So I want to make a method that takes an array as a parameter and then computes the sum. So I believe that's what we're going to be doing next in the methods over here. So it's going to compute the sum of this array that's been given to us. I'm given an integer array here, right? It's actually going to look pretty similar to the pattern that we used up here, I think without the if statement. I have this sum value set to be 0. I'm going to iterate through the array. And now I'll just go ahead and add the values into my sum variable. I think that'll do it, right? So this looks awfully similar to, you know, something like this, especially if I had the method call here. In fact, there's a name for this pattern, starting with an empty string or starting with a 0 and then going through a string or an array and adding everything up. There's a name for this. It's called the accumulator pattern. It's very commonly used. You'll see it pop up all over the place. It may even pop up later today, perhaps. I'm not entirely sure. But yeah, anytime you start with a variable, loop through something, and create a running total or anything like that, that's the use of the accumulator pattern. And here's another good use of it. Let's go ahead and run the tests and see if this satisfies. Here we go, array sum, now passing our test, that's good. If we take a look at, so now we want to take a look at the tests for array sum. They are going to look a little bit different than what we saw before. We can see that the tests that we see make an array, call the method, and tell us what the expected result should be, and then make an assertion. That third value is missing though. So this time, the value that's being returned, the sum, is an integer. And because integers are exact, we don't have to worry about you know, rounding errors or computation errors, things like that. We don't need that tolerance anymore. So this assertion is actually a little bit different. But otherwise, I think these tests make sense. Create an array with values in it, call the method using that array, and then make sure that it equals the sum, which you'll notice that these tests were chosen to be pretty simple, right? Ones that we can easily do in our heads. And then there are a lot more comprehensive tests that you can see that were given as well. But they all, you know, feel somewhat similar in their intent. All right. Now we're going to take a look at this filled array method. Let's go ahead and move on to that in our code. It's telling us to return an array of a given size filled with the provided value. So we want to, if I tell you that I want an array of length 7 and the value of 2, right? That means I want an array with 7 2s in it, right? So you'll notice then that the return type of the array is appropriately chosen as an integer array. This is another thing that kind of trips people up to see this, and actually on the previous one, for that matter, seeing these square brackets here as an indicator that the type of this parameter is actually an array. And the return value here isn't just int, right? That would be a single value. That would be a single value. I'm creating and returning an array here, so the return type here is an integer array. That is how I would construe that. But I need to create this array of an appropriate size. We know how to do that. That's review. New int length using that parameter that was given to us. And now we need to go through and fill it, which I'll use another loop. This is not the accumulator pattern, although it is very similar in some ways. Values at I equals value. Return values. Okay, let's go ahead and run our tests and see how we're doing. Oops. All right. I passed a couple of tests, but did not pass this one. Let's go take a peek. It says the length is 2, the value is 4, right? So it goes and calls my method, asserts that it's not null, asserts that the length of this is equal to 4. But that's not what we said it should be equal to, right? Here's another error with the test. It should be equal to length. Let's try that again. Good. Fixed it. Okay. The next method that we're going to see is a really important one because it's actually the next couple methods that we're going to see to wrap up the studio are important because it shows us really, I think, what methods can really be useful for, how we can use methods to organize our code and make it more modular, more general, and just more practical. So let's take a look at the next method that we're tasked with. We want to create an array mean method which accepts an int array. Okay? And I'm sure they give us more instructions than that. Oh, I've got another little typo here that I need to fix. Sorry about that. Here we go. Array mean. So we can see that we have to declare this as public static. Let's go ahead and get that down. Later on, we'll talk to you about what we might change about these two words, public or not static, just leaving static off. But for now, the methods that we write are going to be both public and static. We need a return type. So if I am taking an average of an array, right? What do we expect the return type to be? Because if the average is an array of 2 and 1, then that's going to be a mean of 1.5, correct? 1.5. So to me, that sounds like a double, perhaps. Now we need to give it a name. It's telling us that we need to, we should call it this, array mean. And then finally, we're going to accept an integer array as our parameter. I'll call it values. Eclipse is angry because we have to return a double here, so we haven't filled this out yet. And at this point in time, so we know how to take the average of the values that are in an array. Well, first we have to take the sum, and then we have to divide by the length of the array, the number of values, right? And so some people will start by going through and typing out the code to go through the array and create the sum. Or some people I saw might come up here and grab this code and then bring it down here. And both of those I would encourage you to resist the urge to do, right? Because there's an easier way, a simpler way, which is to use the method that we have available to us. So this array sum method already exists. Let's use it. I know it returns an int, so let me create an integer to hold that result, the sum of this array. If I want to use that method, I now have to state the name, which is array sum. And then I have to plug in any parameters that it's expecting, which it is expecting an integer array, which we happen to have. So I'm just going to take this one that's been given to us and just plug it right in. Notice, though, the fact that these are both named values here is just a coincidence. This could be named anything. This was named array. That's fine. Let's switch that up, right? Once I get that sum back, I then just have to divide by the length. Okay. I think that'll do it. Let's go ahead and run this. See. Oh, look at that. Passed. It passed. So using the array sum method here really did a nice job of helping us leverage our prior work, right? We've leveraged this prior method to help us solve a more complicated task. That's computer science. That's programming. That's classic programming. But we still actually have a little bit more work to do. So let's take a look at what else they're asking us to do. They want us to write a JavaDoc style comment for this array mean method that we just wrote. So let's go ahead and do that. If you come up here above the method and type /**, Eclipse will know what you mean when you hit the enter key and kind of get you started. So this method computes and returns the right? So that's just a description. Array with values to be averaged. This is a description of what the parameter is. And then a description of what the return value is. There's my JavaDoc style comment. We can actually use these JavaDoc comments later on. You can see down here at the bottom, we might have a little bit of time to do that. But first, let's take a look at the array mean tests to kind of wrap up the coding portion. Here we go. So for small arrays, right, the mean should just be whatever the contents are. You can see we test, okay, there's a nice value. None that are actually requiring a double just yet. Let's see. Here's some more comprehensive ones. So here's one that expects a double. Right? Lots and lots and lots of tests. Thanks to Professor Cosgrove for writing all of these tests for us to help us check our work. The last thing that we can show you is, writing JavaDoc comments is important because you can actually use them to tell other people about your work. So I've already shown you, for example, how to generate comments, or I'm sorry, how to look up documentation online like this. So here's the Java documentation for Scanner. Well, in Eclipse, if you come up to the project and then generate JavaDoc, I'm going to select Studio 5, right? Specifically, there we go, just that one. It's going to put it in, there we go, that's good. And it's going to generate this JavaDoc for me here. And once that's done, what we can do is we can refresh our project and see we've now got this new folder down here called doc. And if I open up the index now, we see, oh, we've got a, this looks a lot like the page, not exactly the same, but very similar to something that looks like this. And actually, if you keep going, click on the methods, for example. Okay, here is description of all the methods that are in the file, but for, array mean, right? That's what I wrote. And if I click on this and go down here, array mean, the method computes and returns the average of the given array with values to be out. This is what I wrote. These are the JavaDoc comments that I wrote. So there's a way to take these JavaDoc comments and present them in a way that is easily accessible to all. In other words, create an API. That's programming. That's what we're trying to do. Make code that's easy to use so that we can share it with other people and they can use it to build cool stuff. All right, I'd like to go ahead and wrap up this review session by introducing you to the next assignment. So this is going to build off of the last assignment. On the last assignment, you were introduced to this concept of zombies. You read in some values from a file. We're actually still going to be doing that. But now that we have this concept of methods, the first thing that we're going to ask you to do is refactor your code from assignment 4. And what that means is that instead of having all of your code in main, this big blob in main like you did for assignment 4, we can now break it up and make it more functional and organized by splitting it up into smaller methods. So that's kind of your first part, but then there's going to be a little bit more new stuff that we're going to ask you to do, including making the zombies move. And so we've provided you, make sure you come down here and look at this recommended workflow. There's a lot to kind of absorb here. If you just dive in and start trying to write code, it's probably not going to go well for you. So take your time, go through it step by step. You will get through it, and you'll also be really satisfied with the final result once you get there. I promise. It's a really, really, really super fun assignment. I'm so excited to see all of the demos in class next week. And last but not least, I'll introduce you to my buddy Franklin. He's my cat. He's a really good cat. Okay, that's all from me. Have a great weekend, everybody, and I'll see you in class next week.